Welcome to this custom-tailored deep dive. We're really thrilled to have you with us today. Our mission for this session is an incredibly exciting one. We are exploring how to navigate, understand, and ultimately master the rapidly accelerating world of artificial intelligence in design.
Yeah, and we are pulling all our insights today from a truly comprehensive book by Mustapha Moussaoui. It's titled Architecture in AI: Controlling the Hallucination.
Which is such a great title, by the way.
It really is.
Yeah.
And it's a phenomenal text. We put this together just for you because it is incredibly timely right now.
Yeah.
Whether you are a practicing architect, a digital designer, or frankly, just someone fascinated by how technology is fundamentally reshaping human creativity.
Yeah.
The shift we are seeing right now is profound.
Right. It's not just a software patch.
Exactly. We're not just talking about a flashy new software update. We're talking about a complete paradigm shift in how things are conceived and made from the ground up.
Okay, let's unpack this. To really grasp the magnitude of the shift we are living through right now, the text offers this incredibly vivid historical analogy. I want you to picture this. You are standing in France, and the year is 1380.
So a very long time ago.
Right, centuries ago. You are inside a towering, half-built Gothic cathedral. Scaffolds are literally everywhere. The noise is just deafening. The master mason is directing the work, and his expertise is entirely physical.
Yeah, and it's in his calloused hands.
Exactly. It's muscle memory. It's these closely guarded rules of thumb passed down through the guilds. He designs at the slow, deliberate pace of cutting stone.
That's the reality of the time, right? His entire authority, his entire livelihood rests on that embodied physical expertise. He's the master of the material.
Right. But then, and this is where everything flips, a courier arrives from Italy holding a rolled-up parchment. On this parchment is a proposed facade for a building, but it's rendered in linear perspective.
Which was revolutionary.
It disrupted absolutely everything. This new technology, the concept of abstract drawing or disegno, meant that suddenly you didn't need to be standing on the scaffold with a chisel to make decisions.
You could see the future building on paper.
Yes. The patron, the person actually paying for the building, could look at the project as a whole before a single stone was ever laid. The power completely shifted away from the builder on the ground to the patron and this entirely new intellectual figure, the architect.
And that brings us directly to our mission for you today. In our current era, AI is that new roll of parchment. It is the new medium of abstraction.
It's the new drawing.
Exactly. The goal of this deep dive is to equip you with the knowledge to control the AI's outputs, what the author calls its hallucinations. If you don't learn how to read this new parchment, you risk being demoted to just a passive prompter, letting the machine make all the important decisions. We want to help you secure your creative agency.
So to do that, it seems like we first need to completely deconstruct how we even talk about AI, because we constantly hear the phrase artificial brain. It's in every headline right now. But the text argues we need to drop that metaphor entirely.
Drop it immediately, yeah.
Why is thinking of it as a brain so counterproductive?
Because it implies consciousness, which implies reasoning. The book suggests a much better metaphor, which is an engine. If you look back, the steam engine was built to generate mechanical force. The early computer was an engine built for logic and calculation.
Or calculators on steroids.
But modern AI, it is an inference engine. It doesn't think or know anything. It infers patterns, and its fuel is massive amounts of data.
That makes a lot of sense. But people have been dreaming about building an artificial brain for a long time, right? I mean, this isn't exactly a new ambition for humanity.
Oh, not at all. We connect this to the bigger picture. The dream of an intelligent, non-human creation is ancient. The source material traces this all the way back to mythology. You have the Golem of Prague, which was molded from clay and brought to life.
Oh, wow.
Yeah, or Telos, the giant bronze automaton guarding the island of Crete in Greek myth. But the formal mathematical journey really started with people like Gottfried Wilhelm Leibniz in the 17th century.
The philosopher.
Yes. He dreamed of creating a universal language of reason, a literal way to calculate human thought. Fast forward to 1950, and Alan Turing completely reframes the issue. He stopped asking the philosophical question, can machines think? And asked the strictly operational question.
Which was?
Can a machine behave in a way that is indistinguishable from a human? It's all about behavior, not internal consciousness.
Which brings us to the first major era of AI, The text calls this GOFAI, good old-fashioned AI, or symbolic AI, which was huge in the 70s and 80s. But from what I understand from the reading, it was a massive failure.
A spectacular failure, honestly.
Why did that approach hit a brick wall?
Well, GFAI relied on human programmers manually writing thousands and thousands of rules into a database. It was very literal. If this happens, do that.
Sounds exhausting.
It was. And the real world is infinitely messy. You can't program common sense into a machine line by line. The systems became incredibly brittle. They couldn't handle ambiguity at all, which led to a massive freeze in funding and research that we now call the AI winter.
The AI winter, that sounds incredibly frustrating for the researchers at the time, but obviously winter didn't last forever. What thawed it out?
During that winter, a totally different paradigm was quietly growing in the background. It was called connectionism, and it was built around neural networks. The idea was radical, but actually quite elegant.
No, so?
Instead of programming a machine with rigid human-written rules, what if you just showed the machine millions of examples and forced it to learn the underlying patterns on its own?
Wait, so nobody's actually telling it what a building looks like? It just figures it out by staring at photos?
Essentially, yes. And what's fascinating here is how this exploded into the mainstream in 2012. A deep neural network called AlexNet was entered into ImageNet, which is this major image classification competition.
Like a science fair for AI.
Exactly. And AlexNet didn't just win, it absolutely shattered the existing records. It blew the rule-based systems completely out of the water. That was the watershed moment. That triggered the massive explosion of the modern data-driven AI we are dealing with today.
Which brings us back to that term from the title, the hallucination. Let's say I sit down at my computer right now and I ask an AI to generate an image of a brutalist library on Mars. What is the AI actually doing if it isn't reasoning? Because it sure looks like it understands what I'm asking for.
It looks like it, but it doesn't actually know what concrete is, or what a book is, or what the Martian atmosphere feels like.
And what is it doing?
It is dredging up statistical patterns from the billions of images it consumed during its training.
Yeah.
It finds the visual statistics that correlate with the word brutalism,
Yeah.
the visual statistics for a library, and the color palettes and textures associated with Mars.
It's just doing math.
Pure math. Then it synthesizes a plausible blend of those statistics. It is essentially unreasoned dreaming. It's a highly sophisticated parlor trick of probability.
That is wild. But to control that dream, the book says we have to understand the anatomy of the machine doing the dreaming. The text breaks down a few of these core architectures. First, it mentions CNNs, or convolutional neural networks. What is their specific job in all of this?
CNNs are the models that originally gave AI its spatial awareness. They are incredibly good at scanning images locally. They start by detecting simple edges, then they combine those edges to understand textures, and then they combine those textures to recognize whole objects. They are the eyes of the operation.
Okay, that makes sense. Then the book introduces Jan's generative adversarial networks. That sounds incredibly intense, like a sci-fi movie. What does adversarial mean in this context?
It is a bit like a rivalry. Think of it, Jan, like an ongoing battle between an art forger and a police detective.
Oh, I like this analogy.
Right, so the forger, which is the generator network, tries to paint a fake masterpiece from scratch. The detective, the discriminator network, looks at the painting and tries to spot the flaws to prove it's a fake.
And then they just keep going at it.
They go back and forth millions of times until the forger gets so incredibly good at its job that the detective simply cannot tell the difference between the fake image and reality.
That is a brilliant way to picture it. But then we get to diffusion models, which is the architecture behind current powerhouses like Midjourney. And this one operates completely differently, right? How does diffusion work?
Diffusion works through destruction and recovery. It takes a perfectly clear image and slowly adds digital noise to it layer by layer until the image is completely destroyed. It just looks like meaningless TV static.
Just gray fuzz.
Exactly. Then the AI learns how to mathematically reverse that exact process. Once it learns the reversal, you can hand it pure, random static, and it will pull a coherent, entirely new image out of the noise.
Wait, so it literally starts with TV static and just sculpts a building out of it. That feels like magic. But how does the AI know what to pull out of the noise? Where is all that architectural knowledge actually stored?
That is where the author introduces a brilliant concept called latent space. Imagine a high-dimensional map. This map contains every single concept, texture, and relationship the AI has ever learned. To use this map, the AI relies on an encoder and a decoder.
Okay, let's break that down. What does the encoder do?
The encoder takes a complex piece of data, like a highly detailed photograph of a Gothic cathedral, and compresses it into a specific mathematical address on this giant map. That address is called a latent vector.
Got it. It pinpoints the location, and the decoder does the opposite.
Exactly. The decoder takes that specific mathematical address on the map and unpacks it, translating it back out into a fully realized, detailed image.
So to bring this back to you, the listener, why do you need to care about latent space? The author calls this out as crucial. The book calls it an intentional act of design.
It is the core of modern design practice.
Right, because navigating this map isn't a random lottery. When you type in a text prompt, you aren't just crossing your fingers. You are literally steering the AI toward a specific semantic neighborhood on this massive map. You are driving the machine toward novel possibilities.
And driving that machine represents an incredible shift in how we create. It's helpful to look at the evolution of architectural tools mapped out in the text to see just how big this leap is.
It's a long journey.
It is. For centuries, we started with direct, tactile engagement using stone tools. Then came the abstraction of geometry, the rope stretchers in ancient Egypt, the complex tracing floors of those Gothic cathedrals we talked about earlier.
Then we leap into the 1980s with CAD, computer-aided design. I imagine that must have felt like a massive disruption at the time.
It was huge because it turned a physical ink line on a piece of paper into a modifiable digital data set. But ultimately, CAD was just digitized drafting. It was still just lines.
It didn't know what it was drawing.
All right. The next massive shift was BIM. Building information modeling. BIM didn't just draw a wall, it created a digital twin. Every digital wall or window in a BIM model has embedded data about its actual cost, its thermal energy performance, its physical weight.
It's a simulation of the actual physical object.
Yes. And after that came parametricism, using visual programming tools like Grasshopper, where design became an algorithmic system governed by mathematical rules and relationships.
Here's where it gets really interesting. AI is the next leap, and it's a completely different paradigm from all of those. The text references a 2015 prediction by Richard and Daniel Susskind, who foresaw intelligent systems automating the professions. But it seems like AI is doing more than just automating the boring stuff, right? It's acting as a co-ideator.
That's the key distinction. We are seeing tools like Autodesk Forma being used for pre-design, running instant complex environmental analyses on how a building sits on a site.
And on the aesthetic side,
we see Midjourney generating highly complex conceptual forms in seconds. We see platforms like Swap.ai automating the tedious, repetitive production of construction documents. The architect is no longer just drawing a building. They are curating computational thought.
But that brings us to the core warning of the book. What happens if you, as the designer, don't actively curate that thought? What if we just let the AI do its thing on autopilot?
If you do that, generative AI has a severe built-in tendency to regress to the mean. It produces what the author calls smooth architecture.
Smooth architecture. What does that actually look like in practice?
Because AI generates images by blending statistical averages, its default output is completely frictionless. It creates these homogeneous, visually pleasing, but ultimately hollow designs.
So they look good at first glance, but there's nothing there.
Exactly. They completely lack the specific, stubborn friction of the real world, the constraints of a unique physical site, the nuances of local culture, the realities of gravity and physical materials. It makes everything look like a generic, slick corporate rendering.
And the book points out that this smoothness is a direct result of the data the AI was fed, right? The source material points out a data reality here, noting that the machine's imagination is literally limited by its data diet.
Yes, it's a structural bias in the data sets themselves. The data scraped from the web to train these models mathematically overrepresents Western high-capital architecture.
So, lots of glass and steel.
Endless photos of glass skyscrapers in New York or London. Conversely, the training data largely lacks representation of indigenous and vernacular architectural traditions. So if the AI doesn't have the data for a specific regional building style, it simply cannot generate it. It defaults back to that Western, glossy, homogeneous average.
So what does this all mean for the listener? How do you avoid falling into that trap of just churning out smooth, average buildings?
The book uses a great term here, avoiding epistemic apathy.
That's a mouthful.
It is, but it's really just a fancy way of saying we get lazy and stop questioning where the machine is getting its ideas from. To fight this, the author outlines 3 new roles you must adopt. The first is the curator.
What does the curator do?
You have to actively select and inject diverse, unexpected data into your workflows to force the AI out of its comfort zone. You bring the friction back.
Okay, what's the second role?
The second is the director. Like a film director guiding an actor, you have to steer the machine through constant iterative feedback. You don't just accept the very first image it spits out. You mold it, you push it, you refine it.
And the third role is the system builder. This is where you move beyond just typing simple prompts and start actually constructing your own bespoke generative workflows, tailoring the AI to your specific design ethos.
Exactly. It means the era of the lone genius sketching a masterpiece on a napkin is making way for a hybrid co-creative intelligence between human and machine.
To achieve that level of co-creation, you need practical skills. And the source material actually provides a deeply practical guide focusing heavily on Midjourney. It starts by distinguishing between the two primary ways you can interact with the platform, the Discord interface versus the web interface.
Both are valid, but they serve different needs.
Let's break those down because they offer very different experiences. Discord is the original way Midjourney operated. It's heavily command line oriented. You are literally typing out / commands in a chat box.
Which can feel a bit intimidating at first.
It can, but it is fantastic for granular control and batch experimentation. The book highlights the /blend command, which lets you seamlessly merge two completely different spatial typologies together. Or my personal favorite, /describe.
The /describe command is absolutely fascinating.
It really is. You upload an existing image, and the AI reverse engineers it, giving you 4 different text prompts that could have generated it.
It feels like letting a magician look at your card trick and having them tell you exactly how you hid the card up your sleeve.
That is the perfect way to describe it.
On the other hand, the web interface is highly visual and UI-based. You're using sliders and buttons instead of code. It's much better for rapid visual iteration. You can easily pan across an image or use in-painting, which they call vary region.
Oh, I love that feature.
It's so useful. It lets you highlight just a specific window or door in your image and tell the AI to redraw just that one specific part without changing the rest of the building.
But whether you are using the code-heavy Discord or the visual web UI, you have to know how to talk to the machine. You have to program it. The book lays out the anatomy of a perfect prompt. It's not just a conversational sentence, it's a structured formula. First, you start with the subject. Let's say a futuristic villa.
Next, you add attributes. This is where you specify the physical details. For example, flowing organic shapes, large glass walls. Then you establish the context. Where does this exist in the world?
Like putting it in an environment.
Exactly. You might add set on a cliffside overlooking the ocean, dusk lighting.
After context comes style. You want to give the AI a clear artistic direction, so you might append cyberpunk style or photorealistic architectural render. But the real magic, the real control, happens at the very end of the prompt with the parameters.
The parameters are the secret sauce.
These are the specific technical codes you type to force the AI's hand.
Parameters are absolutely vital. You have --AR for aspect ratio, which allows you to force the image into a wide cinematic 16:9 format, or a tall vertical format. You have --V to select the exact version of the Midjourney model you want to run. You have --Q to control the rendering quality.
And I've always wondered about the stylized parameter --S. How does that actually change the output?
It dictates how much artistic liberty the AI is allowed to take. If you drop it to --S0, the AI tries to make the image look as literal and unartistic as possible based on your prompt.
So very dry and straightforward.
Exactly. But imagine you were stuck on a concept for that Mars library we talked about earlier. You type --S1000, and suddenly the AI ignores strict constraints and gives you something wildly sculptural, highly stylized, and abstract that you never would have thought of on your own.
It just goes wild. And the book also mentions combining the --chaos parameter with the --repeat command. What does that do?
If you really want to explore that high-dimensional latent space map, this is how you do it. This tells the AI to generate multiple images at once, but forces every single image to be as wildly different from the others as possible.
So you get massive variety immediately.
It is a brilliant way to instantly generate a massive, diverse matrix of conceptual variations for a single idea in seconds.
The ultimate takeaway for you here is that mastering these specific structures and parameters is how you enforce your will upon the machine. It is how you ensure the AI's hallucination is bounded by your exact architectural intent, rather than just settling for whatever pretty, smooth picture it decides to spit out.
Which brings us back to where we started at 1380. Embracing AI is not about surrendering your creativity to a computer. It is about evolving your literacy. Just as that master mason had to learn the new language of abstract perspective drawing to survive the changing market, today's learner must master the latent space.
You have to adapt.
You must learn the grammar of prompting and the logic of neural networks to retain your agency.
It's entirely about staying in the driver's seat. Well, before we wrap up today, we want to leave you with a final provocative thought to mull over on your own, something that builds on everything we've discussed today about optimizing design.
Consider this. If AI eventually masters the perfect, frictionless optimization of form, function, and logic, does the sheer, stubborn imperfection of human intuition, those deliberate mistakes and the physical friction we bring to a space, does that become the ultimate irreplaceable luxury in the future of design?
That is a fascinating question to chew on. Is human flaw the ultimate luxury? We want to thank you for joining us on this custom-tailored deep dive into architecture and AI. We hope this gives you a powerful new framework for navigating your own creative processes. Keep questioning, keep learning, and start architecting the dreams of the machine. Until next time.